Welcome to my presentation on visualizing quantum gravity. Well, we need to start by explaining what is quantum gravity. Quantum gravity is a theory of how structures like this galaxy are held together by gravity that is generated by quantum properties of matter. I mean, it has to be a field theory. Gravity fields have very well-known properties. And forget about particle exchange theories. I mean, in our solar system alone, we have over 10 to the 57 nucleons. Each of those is supposed to swap gravitons or something and attract each other and then interact with electrons and photons in the same manner to get the same gravity attraction. Forget it. It's just not going to happen. Forget about string theory. It uses particles that are too small to ever be detected and has dimensions that have never been detected. And I must say that the results, if any, are rather difficult to detect. And here's where I'd say that I have an advantage. This is a picture of a Robinson detector. These were developed at a time when world experts said this type of imaging would never work. Yes, well, experts. But it did work. I went on to develop other techniques for use in scanning electron microscopes that provided a huge amount of information that couldn't be provided by other means. And I must say that it worked because I used common sense. And this presentation is about trying to see if the same common sense approach can be used to solve one of the greater problems, the origins of gravity, and particularly quantum gravity. This presentation uses only 3 space dimensions and time, along with known physical properties and constants. Everything used has been known for at least 60 years. The relevant factors are combined in a common sense manner. It's mainly a descriptive presentation. Some mathematics, of course, are necessary. And those maths, an equation is derived in which the first approximation is Newton's inverse square law. Einstein's field equations provide a second approximation. The exact solution can be used to solve any gravity situation. And it explains a lot of unknowns in cosmology. To visualize quantum gravity, it is necessary to understand what is correctly known about gravity. The title gravity originated from the Latin word gravitas, a grave, heavy, or serious subject. The word gravity was introduced about the 16th century. Gravity is the first force we experience. It was the first to attract human attention. The ancients, the Greeks and Romans, attempts to understand why things fell down were concluded with, well, there's a trend for everything to go to ground level, or words to that effect. Since those ancient times, most studies of the movements of planets were oriented towards a geocentric model of the universe. It was considered the sun and planets moved around the Earth because of gravity. Copernicus suggested the sun was the center of planetary motion. Bray made detailed studies of the motions of the planets in the night sky. His assistant, Kepler, used Bray's detailed results to work out what are now called Kepler's laws of planetary motion. Note that portraits are from Wikipedia. The publication dates follow their names. Galileo Galilei used his telescope to study the motions of planets in the night sky. He found their paths only made sense if they were orbiting about the sun and not Earth. He also observed 4 moons orbiting Jupiter. He was duly rewarded by house arrest and told not to tell anyone. Experts didn't like change back then, did they? Sometimes wonder if that has changed in this modern era. Isaac Newton used calculus and other maths to put mechanical engineering onto a firm basis. In the first volume of his Principia, he dealt with gravity. He introduced the inverse square law of gravitational force, the attraction between two bodies of mass m1 and m2, with their products multiplied by a gravitational constant and divided by the distance between their centers of mass squared. That gave acceleration due to gravity is just gm over r squared. Among other gravity studies, he also showed that if gravity was inverse square, a planet would trace an ellipse with the sun as one of the focal points. The elliptical path would not vary. That is illustrated here, where gravity is inverse square, the planet will always travel the same path, always returning to the same aphelion point. In Proposition 45 of his Principia, Newton worked out that if gravity was weaker than inverse square, a planet would orbit a little further away from the sun and be attracted by a weaker force. It would travel further to return to its aphelion position, which will then precess in its rotation direction. That is shown here. It travels a little bit further away than here, so it has to travel a little bit further and take a little bit longer time to reach its aphelion position. And it continues doing that, and its aphelion position then will precess in its direction of rotation. But conversely, if gravity was stronger than inverse square, it will orbit a little closer to the sun and be attracted by a stronger force. This is shown here. It will complete each orbit sooner. So it will return to its aphelion point a little earlier, and then repeated, a little earlier still. And in that way, its aphelion will regress against its direction of motion, of rotation. He also worked out that gravity acted as if all the mass was concentrated at the center of a body's mass. He determined that gravity was universal. It held things on Earth. The biggest problem with Newton's gravity was that he didn't give a physical reason for it to act. He settled for a known action at a distance for unknown reasons. On the positive side, he laid the mathematical foundations for how gravity worked. His equations predicted almost every observation for almost 200 years. That was a little bit shorter than the gold standard he introduced to the Bank of England to keep the finances under control. Yes, he was quite a bright person. Leverrier pointed out that Mercury's orbit was precessing faster than predicted when all Newtonian effects were calculated. He suggested that there was another planet he called Vulcan orbiting inside Mercury's orbit and could give a little bit of an attraction towards it. That planet was never found. Studies compiled by Newcomb indicated that Mercury's anomalous orbital precession was about 43 arcseconds per century. In 1911, Einstein applied Newton's gravity to photons that he previously indicated had mass. Out of that, he derived an expression for photons being redshifted when they moved away from the sun. That was the beginning of his gravity publications. In 1915 and 1916, he solved both problems: what was causing gravity and Mercury's anomalous orbital precession. In his general relativity theory, he proposed that mass distorted space-time to produce gravity. He used that to solve the riddle of Mercury's anomalous orbital precession of 43 arcseconds per century. He showed that photon trajectories would be deflected as they passed close to the sun. Einstein also predicted that massive objects orbiting each other would lose energy as they emitted gravity waves. All of those were later verified, giving gravity a significant improvement our knowledge of it. Einstein developed a set of gravity field equations. The maths he used were so complex that only experts attempted to understand them. He also indicated that Newton's gravity was a first approximation to the field equations of his gravity theory. Here are a couple of examples of his gravity field equations. Good luck in understanding them, let alone solving them. Another problem with his work was that nobody knew what space-time distortion meant physically. Einstein's work still left some problems. The complexity of his field equations meant that none of those who expanded on his work understood them. When they solved them, they derived this term, where alpha equals 2gm over c squared. It has this 1 minus alpha over r term, which predicts that gravity will be stronger than inverse square. That solution predicts black holes, which Einstein did not believe. Those experts did not know the physics that underpinned them. That is, what physically is space-time distortion. I solved both of those with my presentation, Physical Explanations of Einstein's Gravity, published in an Institute of Physics Journal of Physics Communications. The details of it can be found at these two addresses. In it, I showed that mass distorting space-time was photon redshift, denoted Z. Distances are determined by photon wavelength. A change in photon wavelength means a change in distance. It is accompanied by a change in frequency, which means a change in time. They are what space-time distortion means. The other thing that many people are not aware, Einstein's gravity field equations calculate the difference between his theory and Newton's inverse square law. They are not absolute. In that paper, I showed the exact solution to Einstein's gravity field equations was given by this term, where the 1 minus alpha over r has been replaced by 1 over 1 plus alpha over r. That solution was also derived directly from Einstein's 1916 foundation paper without using his field equations. It's on the Quicycle website. It's a straightforward four-dimensional differential that was expanded to all 16 terms. These were then filled in from Einstein's work. The final touch came from converting Cartesian coordinates to polar coordinates. When r squared in Newton's inverse square law is increased by the dr squared term from this equation, we get g equals gm over 1 plus alpha over r times r squared. Redshift z is alpha over 2r, so that changes this to gm over 1 plus 2z times r squared. I should point out that is combining Einstein's work with Newton's work. Now, so equation 1 is Newton's gravity field equation. Equation 4 is Einstein's field equation solution added to Newton's gravity. The complexity of Einstein's gravity field equations are basically reduced to equation 4. So Einstein's gravity is a minor but important variation to Newton's gravity. So Einstein's gravity is weaker than Newton's inverse square law. That is a physical requirement for Mercury's orbit to precess as observed. It's a strong indication that black holes are not physically possible. Here I just repeat these variations of Einstein's gravity field equations. So complex to follow that those who believe they did follow it derived the accepted Schwarzschild solution. It's an approximation that works when r is much, much greater than alpha, with one exception. The negative sign means it predicts Mercury's orbit should regress. I mean, what's a minus sign between friends in maths? Now here, this is the exact solution. Now, when r is much, much greater than alpha, then 1 minus alpha over r approximately equals 1 over 1 plus alpha over r. I mean, 1 minus a millionth, you get out your pocket calculator and you'll find it's equal to 1 over 1 plus a millionth. It's quite a valid approximation. And that is why the approximate solution works quite well, almost as well as the exact solution, except for this incorrect prediction of Mercury's orbit. The major problem with equation 2 comes when the solution is extended to r approximately equal alpha. What you get, this term becomes 0, this whole term becomes infinity, gravity is so strong, black holes. Yet really, all this complexity, when combined with Newton's work, just gives this equation. I mean, this is the practical solution to Einstein's gravity. Very few claim to be able to handle the field equation solutions for anything more than predicting black holes and the differing times and distances for orbiting satellites. Yet I respectively suggest that some good high school matriculates would be able to use this equation to get absolute results and then subtract Newton's gm over r squared to get the solution to Einstein's field equations. This is not a difficult task. This, good luck. As I said, they've got it wrong. However, with these field equations, Einstein immortalized himself as the great source of gravity knowledge. In his 1916 Foundations paper, he used some 60 A5 pages plus over 100 equations to derive the tensor variations of his field equations and also solve for the bending of light rays from the sun. These are products of all of that work. His choice of tensors unnecessarily complicated what is otherwise relatively, and pun intended, a simple solution. The complete answer to which is just given by the solution. Einstein's field equations, gravity is just this term, gm over 1 plus alpha over r times r squared minus gm over r squared. To that unnecessary complex choice of tensors, he embellished his work, adding unnecessary and confusing equations that made it difficult for experts to follow. Being unable to follow his work, their solutions included black holes in which he did not believe. The other side, had he derived equations 4 or 4a, people would have said, yeah, ho-hum, nothing special, more power to Newton. As it is now, the huge and unnecessary complexity in his field equations and their derivation means he is regarded with the highest esteem. Having said that, he still was brilliant for his era. Here again, I just repeat a couple of examples of his field equation, very difficult to follow, and this is the simple solution of what these equations mean. Now, at the beginning of section 4 of his 1916 Foundations paper, Einstein wrote, which is translated into English, "It is not my purpose in this discussion to represent the general theory of relativity as a system that is as simple and as logical as possible, and with the minimum number of axioms. But my main aim is to develop this theory in such a way that readers will feel that a path we have entered upon is psychologically natural and that the underlying assumptions will seem to have the highest possible degree of security." Well, he certainly was successful in the first part of his statement. His paper is neither simple nor logical, but he was not successful in the second part. None could say his work was psychologically natural. However, it seems to have been sufficient to discourage the best experts from admitting they could not follow what he called his psychologically natural path. The reality is that equation 4a is simple to derive and use. It is not subject to misinterpretation and gives more useful information than his field equations. In reality, the important term is this: combining his variation with Newton's inverse square law. Now, with that understanding of what is correctly known about gravity, we can commence visualizing quantum gravity. I mean, trying to fit gravity into singularity of black hole is impossible. They don't exist. Despite decades of trying, no one has succeeded. I respectfully suggest that maybe somebody can fiddle the maths, but you won't get a physical description. Now, what follows was done with knowledge of Einstein's gravity field equations, but they were not needed and were not used in this study. Occasional mentions are made of how his work fits this presentation. To understand quantum gravity, two major features are required. The first is to find a property of space that can generate gravity. The second is to find a quantum property of individual particles that can alter that property of space. Quite straightforward, really. Well, the first feature is quite straightforward. Empty space has two properties of interest: electric permittivity, denoted epsilon, and magnetic permeability, denoted mu. Electric field strengths vary as 1 over r squared. Magnetic field strength varies as 1 over r cubed. In matter-free space, magnetic permeability is given a fixed value, 4 pi times 10 to the minus 7 henries per meter. With that, we need only consider electric fields. They are transmitted through space by its electric permittivity. Maxwell pointed out that the speed of light in vacuum, c, was given by c squared equals 1 over epsilon naught and mu naught, where epsilon naught and mu naught are their properties in matter-free space. Huygens, 1690, pointed out that the refractive index of the medium, denoted Nm, was determined by the speed of light in that medium. That gives Nm equals C over Cm. That turns around to be the square root of epsilon m over epsilon naught, because magnetic permeability is fixed. Epsilon m refers to the electric permittivity of the medium. The speed of light through medium m is given by Cm equals C over Nm, which gives this term, C over the square root of epsilon naught over epsilon m. Photons going from a region of high electric permittivity to lower electric permittivity will undergo a redshift Z given by, these are your standard terms. So it's lambda naught over lambda m minus 1. Rearrange, that gives lambda naught over lambda m equals the refractive index equals 1 plus z. That reduces to epsilon m over epsilon naught equals 1 plus z squared. The above calculations apply to any medium. It has been observed, and Einstein predicted, that photons are redshifted from the sun and other massive objects. Equating gravitational redshift to the same mechanism is easier to recognize if epsilon m for a medium is changed to epsilon g, indicating its contribution to gravity. In my earlier mentioned paper, I derived the term 1 plus z equals e to the alpha over 2r. Combining that equation with equation 6 then gives epsilon g equals epsilon naught e to the alpha over r. Is gravity caused by the changing electric permittivity of space? Well, from Huygens' work, we know that the speed of light depends upon the refractive index and through that, the electric permittivity. When there is a change in refractive index and hence permittivity, photons are deflected. And this is a classic diagram and shows what has been known. Photons coming in from refractive index approximately 1 enter at an angle to a surface, they're deflected, slowed down in the higher refractive index, and when they re-emerge to the low refractive index, they're diffracted again. That's why when there is a change in the refractive index and hence epsilon, photons are deflected. The rate of change from epsilon naught to epsilon g is given by the radial differential of epsilon naught over epsilon g. And showing here, that is the relationship between epsilon g and epsilon naught. So that rate of change becomes the d by dr of epsilon naught over epsilon g equals d by dr e to the minus alpha over r equals minus e to the minus alpha over r squared equals minus 1 over r squared e to the alpha over r. Standard differential theory, but you probably have to be towards the end of an undergraduate mathematics degree to know it. Now, that rate of change requires a constant of proportionality to determine the deflection delta. Using Newton's g and mass m as that constant gives the deflection delta equals minus gm over r squared e to the alpha over r. The minus sign in equation 10 means the deflection delta is in the opposite direction to the radius. And it's the same term as Einstein used in his field equations when he indicated they were dependent on the square root of minus g equals 1. So if deflection is equivalent to gravity, that gives g equals gm over r squared e to the alpha over r, which can also be written as gm over r times 1 plus z, all squared. This term shows the relationship with Einstein's suggestion that mass distorts space-time. The distance r became the distance r times 1 plus z. The whole thing is then squared. Now, this term is the exact solution to this. Equation 11 was independently derived in my 2021 JPhys Com paper. That indicates that GM proportionality constant is valid. Now, when alpha is much, much, much greater than r, alpha over r is 0, and e to the alpha over r equals 1. That changes the deflection to g equals gm over r squared, which is Newton's inverse square law. When alpha is much, much less than r, e to the alpha over r equals 1 plus alpha over r. And that gives this equation, which is the Newton plus Einstein equation. Now, equation 1 has no detectable redshift term. Yet the e to the alpha over r equals 1 plus the z squared term from equation 11 still applies. Gravity is caused by space-time distortion, i.e. photon redshift, even when it is not detectable. In that manner, Einstein can claim that Newton's gravity is a first approximation to his gravity theory. The exact gravity solution, g with gm over r squared e to the alpha over r, was derived with knowledge of, but without using Einstein's gravity field equations. Treating gravity as photon deflection due to changes in the electric permittivity of space gives Newton's inverse square law as a first approximation, and the solution to Einstein's gravity as a second approximation. Equations 4 and 11 both show that gravity is weaker than Newton's inverse square law. The only way that gravity could be stronger than inverse square is for mass to make the electric permittivity of space surrounding it weaker than that of matter-free space. Now, that really would make for some interesting physics. Here, we just have a situation in which you have a large mass M with N nucleons generating a changing electric permittivity around it. The shades of gray indicate the variations. The brighter the gray, the stronger the variations, and the darker the gray until you get to black, the lighter, the lesser are the variations. The black represents epsilon naught, the electric permittivity of matter-free space. The dashed lines represent lines of equal electric permittivity. What you have here is photons coming in. As it passes at an angle to the equal electric permittivity, it's deflected. It then reaches its point of closest approach and then passes again through, this time increasing electric permittivity. Its deflection gets less. The actual amount of deflection, which is shown by these straight lines joining the incident path versus the exiting path, the actual deflection is just 4 times the redshift, where the redshift is from its point of closest approach to infinity. Now, the reason why we know that this is redshift, because the higher epsilon g here means that photons travel slower here. When they get to here, their speed increases, and that because their speed increases, their wavelength increases. And that's your photon redshift. So this is a strong indication that gravity is caused by mass changing the electric permittivity of space, at least for photons. But before moving on, to help you understand it a little bit better, I got a plot of the 4 different gravitational fields. The horizontal axis is just the distance from the center of mass of the massive body, which is here, and it's given in terms of the Schwarzschild radius, alpha. On this side, you have the relative gravitational field strength. If you want to know what they are, you pick on some value at some distance, move across to here, and multiply this term by GM. Now, these curves are produced by getting the various gravitational field terms and plotting them. This is the full Schwarzschild metric. It shows that gravity is stronger than inverse square as they predict. The actual Schwarzschild solution is just the difference between Newton's equation and this equation. Now, these were all produced by just drawing them out for one quadrant. This quadrant was then rotated through 180 degrees and placed here. In turn, this set was then rotated around the zero gravity to get these here. These represent a 2-dimensional slice through a 3-dimensional representation of all of the gravity fields. I said Newton's gravity will go to infinity at r equals 0. Einstein's gravity will do the same. But what is interesting is this redshift gravity. As r gets closer to alpha, it goes through a phase where GZ is at a maximum at about 0.5 alpha. Now, what this means, of course, is that gravity attracts to the region of strongest gravity, which is here. Now, because this is plotted in terms of the Schwarzschild radius, alpha, you can fit anything you like into this, and you'll always get the same result. Incoming particles attracted to here will have a velocity equal to about 0.7 c. Now, for electrons, a velocity of about 0.7 c corresponds to a temperature of about 10 to the 10th degrees K. So what you would have is a huge number of collisions here where the temperature would be about 10 to the 10th degrees K, with very few collisions on the inside and these just sort of petering out. So you'd expect that the radiation would be emitted from a torus shape, something like this. What they actually observed, and these are taken from the Event Horizon Telescope collaboration looking at the center of galaxy M87, I respectfully suggest that these are not black holes. Now, the above figure, which has shown this diffraction, and these equations indicate that changes in electric permittivity of space deflect photons, as given in this equation. Turns out equation 4, the full Einstein gravity solution, is just an approximation to this equation. The earlier presentation showed that photons are attracted by gravity. That's what this is all about. But gravity also attracts matter. We all experience that. And that is the second part of the puzzle. How can mass both change the electric permittivity of space and then respond to that change? Well, it's called quantum gravity. So let's get on with it. The great majority of the mass of the universe is made up of protons and neutrons. Dark matter, dark energy, look, they've not been detected and are not needed and are not considered. In my studies, I've used a model of matter in which all individual subatomic particles consist of photons of the appropriate energy making 2 rotations per wavelength. It has explained a large number of properties in both quantum and relativity fields. It also explains a large number of unknowns in nuclear physics, like the origins of the strong nuclear force in nuclear binding, the nuclear skin effect, the lattice structure of nucleons, isotopes. Indeed, most of the unknowns nuclear physicists want to know, but don't. These figures are visualizations of what nucleons look like. An important feature is that the rotating photon is the particle. Einstein pointed out that photons had mass in 1905. That is what gives these particles their mass. Now, further details can be found in this book on Common Sense Universe, which I have compiled. It's available through Quicycle.com and from the Quicycle website. But just as the briefest introduction, the green curves represent the magnetic lines of force. The electric charge is generated in the axis of rotation of the photons. In the case of protons, it is entirely positive. In the case of neutrons, it has a positive central core followed by a reasonably strong negative inner part, a weak positive outer core, and a very weak negative field. Look, the important feature is that rotating photons have frequencies that vary with their mass, given by this equation. The electron from a mass of 0.511 MeV per c squared has a frequency about 1.2 times 10 to the 20 hertz. Protons and neutrons are much larger, 2.27 times 10 to the 23. Now, we all know the electrons have a Zytterbewegung. That ZBW is twice the photon frequency. An electron Zytterbewegung is caused by the alternating nature of the electric field as it rises and falls twice per wavelength. The nucleons have the same oscillating electric field, although at higher frequencies. Additional to those, the protons and neutrons have a series of 1/3 frequency harmonics, and they have frequency of 7 times 10 to the 22, 2 times 10 to the 22, and 8 times 10 to the 21 hertz. These are for 1/3, 1/9, and 1/27th harmonic, respectively. It's worth pointing out that the properties of the 1/9 harmonics are the same as those of muons. The properties of the 1/27th harmonics are the same as those of pions. These aren't something that are made up. These really exist. But out of all of that, I'd just like you to know that there is a lot of out-of-phase frequencies. To realize what those frequencies mean, we need some of Feynman's brilliance. In chapter 31 of volume 1 of his physics lectures, he addressed the topic of the refractive index of a material. He indicated that electrons behave like little oscillators. He further indicated the oscillating electric field they produced would change the refractive index of the medium by changing its electric permittivity. He developed his approximate field equation, which is 31.9 for the refractive index of a medium, as this, where the n rho is just the electron density, QE is simply the electric charge, E, m, the mass of the electron, omega naught is the frequency of the oscillating electrons generate, and omega is the photon frequency. Combining these equations with Feynman's equation gives us the redshift Z, the square root of epsilon m over epsilon naught minus 1 equals Feynman's equation. The Feynman's equation 13, just repeat it here, applies because the oscillating electrons in the medium affect other electrons. For that reason, the charge and frequency terms in this equation are squared. The general principle is that oscillating electric fields generated by moving electric charges changes the medium's electric permittivity. Applying the same principle to matter-free space means we only have one unit of charge and one frequency instead of their square. The electron density is replaced by the total number of oscillating nucleons. In the denominator of equation 13, the m term refers to the mass of electrons that respond to the electric field oscillation. With nothing in matter-free space to respond to the oscillating electric field, there is no need for that term. The term 2 is used because electrons both generate a frequency and respond to the frequencies of others. With frequencies only generated and nothing responding, it is not needed. The strength of the electric field is proportional to QE over epsilon naught. With one of the QE terms removed, the epsilon naught term is also removed. This study is about the changes to the electric field permittivity, not the electric field's strength. The random nature means the oscillation frequencies will continue to increase until a maximum frequency is reached. After that, further oscillations will increase the amplitudes. Typically, that would occur with about 10 to the 25 nucleons, well under a kilogram. That maximum frequency could be the inverse of Planck's time of 5 times 10 to the minus 44 seconds. Planck's time is associated with the largest frequency that photons can have before they self-collapse into a black hole. It is not a realistic limit, but that does not mean there isn't a maximum frequency omega m. When all of those are taken into consideration, this equation 13 simplifies to the redshift as an approximation of a function times the number of nucleons times electric charge over the maximum frequency. Equating Z to gravity in equation 14 is the redshift going from epsilon g to epsilon naught, going from nearer mass to infinity. N is the number of nucleons in the mass. E is the unit electric charge. Omega m is the maximum frequency from the oscillating nucleons. The term Fn is a function that covers all other factors that may not have been included. The omega term is dropped for now because it is much lower than omega m. Equation 14's N converts to m, mass in kilograms, using 6 times 10 to the 26 nucleons, approximately equals 1 kilogram. Charge is the unit electric charge of 1.6 times 10 to the minus 19 coulombs. By arbitrarily setting omega equals 10 to the 44, equation 14 becomes Z as a function of 6 times 10 to the 26 m times this, which simplifies to a function of 1 times 10 to the minus 36 m. And conventional redshift measurements are denoted Z star or alpha over 2r, which equates to gm over rc squared. Now, for the sun, m is 2 times 10 to the 30 kilograms. That gives the redshift a function of 2 times 10 to the minus 6. Now, for the sun, the conventional redshift has been measured and calculated from Newtonian mechanics to be 2.1 times 10 to the minus 6. Now, the agreement between Z and Z star suggests there is a relationship between electric permittivity and photon redshift. But the sun is not the only body in our solar system. These calculations were repeated for all the planets in the solar system. And note the Fn terms form into 4 groups. The gas giants, the Sun, Jupiter, and Saturn, Fn is approximately 1. The ice giants, Uranus and Neptune, Fn is approximately 30. The large rocky planets, Venus and Earth, Fn is approximately 120. The small rocky planets, Mercury and Mars, average is about 3,600. In round figures, the differences are 4,000. The differences between the mass of the Sun, which is 2 times 10 to the 30 kilograms, and Mercury, 3 times 10 to the 23 kilograms, is about 3 million. A difference of 4,000 in 6 million is 0.015%. Newton's gravitational constant G is usually stated as 6.673 times 10 to the minus 11 meter cubed per kilogram second squared. Several experiments have measured G to an accuracy of an additional 3 significant figures. Those measurements differ by about 0.015%. So these differences are approximately the same in percentage terms, even though some of these absolutes look, well, they look large, but in percentages, they're quite small. Equating equations 15 and 16 just gives the term Z as a function of 6 times 10 to the 26 m times E over omega m, that equals g m over r squared equals Z star. G, M, R, C, and Z star values in that have been measured, so must be treated as accurate. The Z term has the variables Fn and omega m. The M terms cancel out. But with everything else constant, a decrease in omega m increases Fn. The orbital information from satellites orbiting a body, e.g. the Moon orbiting Earth, gives the product of Gm. Measurements of G on Earth give G equals 6.67 times 10 to the minus 11. That is the origin of masses given in Table 2. From that, setting Fn equals 1 gives omega m equals 10 to the 42 Hertz for Earth. Table 2 shows the variations of the omega m term setting Fn equals 1 for all objects. The omega m terms are approximate. The lowest omega m terms are the small rocky planets, roughly 2 times 10 to the 40, 3 times 10 to the 40. Well, in the absence of Fn variation, that allows them to generate the greater gravity for a given mass. They are followed by the large rocky planets, 10 to the 42, the ice giants, 3 times 10 to the 42, and finally the gas giants have the highest omega m terms of about 10 to the 44. The only variables in this equation are Fn and omega m. Although the variations are a factor of about 4,000, spread over a mass of 6 million is less than 0.1%. Although relatively minor, they need an explanation. The nucleons are emitting variable electric frequencies, high though they may be. In spectroscopy, it is known that particles that emit frequencies can also absorb that frequency. That leaves some possibilities. Perhaps the frequencies emitted by inner nucleons are dampened by outer nucleons. That reduces the output for the same number of nucleons, giving a weaker gravitational effect for the same mass. The larger nucleons in closer proximity can reinforce each other, giving a greater amplitude for the same number of nucleons. Or the larger frequency amplitude generated by an overwhelming mass, example the Sun, can influence the output of inner planets and bodies. The Sun's gravitational field strength, i.e. the radial differential of its electric permittivity, is larger than that on the surface of planets until you get out to Saturn's level. However, the general trend is that the larger and less dense objects generate less gravity for their mass, based on Earth's measured g, than do the smaller, more dense objects. The ultimate in small, high-density objects are neutron stars. These are images showing gravitational lensing. In these and similar images, the mass of the central body is determined by its luminosity. There is not enough mass to cause the gravitationally lensed images shown. There's not much mass in that. That is another reason for suggesting that dark matter is part of our universe. Under this rotating photon model of matter, neutrons are a single entity structure. They can be compressed but can't collapse. Large luminous neutron stars could generate the additional gravity needed to explain the observed gravitational lensing. As mentioned earlier, tables 1 and 2 suggested the small rocky planets generated a gravity much larger than the same mass in a star. It is suggested that difference is continued to neutron stars. Despite decades of searching, no sign for any possible dark matter candidates have been detected. This mechanism suggests they are not needed to explain the gravitational lensing effects shown here. So far, I've concentrated on the changing electric permittivity of space-altering photon trajectories. The gravity rule of equation 11, shown here, of which these equations are approximations, apply equally to all masses as they do photons. Whether photons are linear or rotating, they should respond equally to changes in electric permittivity. Because all particles are rotating photons, the same rules apply. And they have a range of frequencies, approximately 10 to the 23 for nucleons, 10 to the 20 for electrons, 10 to the 14 for visible photons. To find out why the response is always the same, we now need to consider Feynman's original equation. In this, omega naught is the oscillating electrons' frequencies that generate the electric permittivity. Omega is the frequency of the photons passing through that permittivity. In gravity, omega m is the equivalent of omega naught, and then that changes equation 15 from this term to this term, which has omega m minus omega. With omega m approximately 10 to the 42, it makes no difference whether omega is 10 to the 23, or 10 to the 20, or 10 to the 14. And that does not change when the terms are differentiated. They will all respond equally to the same electric permittivity gradient, that is, gravity field strength. And that also includes antimatter, which is just the photon of matter particles rotating in the opposite direction. Now, from this equation, the very small value of E at 1.6 times 10 to the minus 19, and the very large value for omega m, approximately 10 to the 42, means it requires a very large n to get any significant effect. That is why gravity is such a weak force, even though its origins are electromagnetic. The very large omega m equals 10 to the 42 means oscillating electric fields will penetrate anything that tries to screen them out. That leaves no way to screen out gravity, and that has also been observed. They and other features mentioned above are known properties of gravity. They all originate from the high-frequency oscillating electric fields of the nucleons, altering the electric permittivity of space surrounding them. There is no physical or mathematical mechanism by which gravity can be stronger than inverse square. That agrees with Einstein's comment that he did not believe black holes could be derived from his field equations. They can't be derived from this work or Einstein's equations using accurate mathematics. Of course, with inaccurate maths, it is possible to derive anything you want. Black holes is one of a long list of such derivations. So, quantum gravity is about how properties of matter particles can change a property of matter-free space that causes other particles and photons to be attracted to them. The most important factors are: 1, the property of matter-free space that mass can change to cause gravity. 2, the quantum structure and properties of matter particles. How matter particles influence that property of space, and then finally, how they all combine to give gravity as we know it. Starting with the first one. Free space is space devoid of matter. Its property of interest is its electric permittivity. It allows empty space to store and transmit electric fields. Photons are little packets of electric and magnetic energies whose fields oscillate and support each other as they travel through space. The electric permittivity controls the speed at which photons can travel through space. Electric permittivity can be changed by oscillating electric fields. Photons passing at an angle through a changing electric permittivity are deflected. The wavelength of photons changes when they pass perpendicularly through a changing electric permittivity. And point 2, all particles are made of rotating photons of the appropriate energy that rotate twice per wavelength. Rotating photons have oscillating electric fields of frequencies between 10 to the 20 and 10 to the 24 hertz. That is the quantum structure of properties of matter particles as applicable to this study of gravity. Now, point 3, those high-frequency electric oscillations alter the electric permittivity of the space around them. The electric permittivity change per nucleon is very small. A large number of nuclei are required to make small changes in photons. The very high accumulated frequencies of the multiple oscillations means they induce electric permittivity in gradual and smooth manner. Consider the sun in this situation. It has 10 to the 57 nucleons within a radius of 700,000 kilometers. Photons passing perpendicularly away from its surface have their wavelength increased by 2.1 times 10 to the minus 6. Photons passing tangentially across the sun's surface will undergo a deflection of 1.74 arc seconds. At a speed of 3 times 10 to the 8th kilometers per second, those distortions occur in a couple of seconds. That is an example of how changing electric permittivity generates the effect we know of gravity. Both are very small values for the very large numbers of nucleons involved. Now, how they all combine to give gravity as we know it. As mentioned, all particles are made of photons of the appropriate energy rotating twice per wavelength. Being photons, they respond to electric permittivity in the same manner as linear photons. That occurs because the accumulated frequencies of the rotating photons are typically 10 to the 42 plus or minus 2 hertz. That is orders of magnitude greater than the 10 to the 23 hertz for nucleons or 10 to the 14th hertz for photons. Rotating photons stay in the same place and are subjected to the same deflection. Consider Earth in this situation. It has about 3 times 10 to the 52 nucleons. We know from experiment that the acceleration due to gravity on Earth's surface is 9.8 meters per second squared. Using Newton's formula of S equals ut plus half at squared, we can work out the distance traveled for different rotations starting at rest. Well, with just one rotation, deflection very, very small. Indeed, it takes a millisecond, about 5 times 10 to the 20 revolutions before it travels just a few microns. But that increases with each revolution, so by the time it's traveled a second, it has in fact traveled the 4.9 meters that we expect from half at squared and 9.8 meters per second squared. That was the situation in which particles were unsupported. They accelerate at the rate due to gravity. But when particles are in a body that is supported, they still undergo the same deflection per cycle. That deflection causes them to exert a force on a supporting body. That is what converts their mass to weight. For the same mass, a body will have a greater weight when its electric permittivity gradient is higher than when it is lower. This equation shows that the gradient is higher when alpha and hence m are larger and or r is smaller. Of course, that's a property of mass. That is a property of gravity. Another feature is shown in this illustration. As the photon gamma approaches its massive object, it enters the zone of higher epsilon g. It is slowed down, deflected, and after it passes its position of closest approach, it speeds up, reaching the lower epsilon g zone. Reaching epsilon naught, it returns to its original speed and frequency. The energy, if we wish to call it, that is lost in the higher electric permittivity zone is restored when it reaches epsilon naught. In that manner, no energy was expended when the photon was deflected. The same happens when a comet passes close to a planet. Its trajectory is altered, but it exits it at the same speed as it approached. There was no force to lose energy. It was just a deflection. In that same manner, gravity can exert a force on a mass forever. Because that force is only a deflection, that mass will never lose energy, nor its gravity get weaker. Photons leaving a high mass, a high electric permittivity zone, are redshifted when they move to the lower permittivity zone. The longer wavelength means a lower frequency. An observer looking at an event of known time will see it taking longer in epsilon naught zone than it did in the epsilon G zone. That changing permittivity is why time is seen to be slower in a higher gravitational field when viewed from a lower gravitational field. I'd just like to do a quick comparison between the three gravity theories. Newton was the first to quantify gravity. He determined its inverse square law. He also determined that mass acted as if it were all located at a body's center of mass. While it may seem obvious now, it wasn't then. And without that knowledge, calculating gravity effects would be very difficult. His shell theorem made calculating other gravitational effects easy. He also worked out what would happen if gravity was weaker or stronger than inverse square. He also showed that gravity was universal. It applied to gravity on Earth's surface as it did to planets orbiting the sun. His contribution to understanding gravity was large, even if he didn't know what caused it. Of course, his gravity field equation is just Gm over r squared. Einstein gave a reason for gravity when he indicated it was caused by mass distorting space-time. He did not indicate, and none of his followers knew, what space-time distortion was physically. He used unnecessarily complicated maths to develop complex field equations that nobody understood. He solved problems like Mercury's anomalous orbital precession, the redshift of photons from the sun, the bending of light rays by the sun, and predicted gravitational waves. His gravity field equations included terms like this and this. As complex as they seem, they reduce to Einstein's gravity field equations just equals this term minus Newton's gravity. They only determine the difference from Newton's inverse square law. That was all he achieved after 60 pages and over 100 equations. They are a minor but important variation to Newton's inverse square law. Einstein's first gravity calculation, the redshift of photons from the sun's surface, was done by applying Newton's gravity to photons he had previously determined had mass. That does not mean Einstein's work was an extension of Newton's gravity. He had a brilliant insight into the workings of gravity in his general relativity theory. His choice of field equations that none of his followers understood says more about their skills, or lack thereof, than his work. Having said that, we can only wonder why Einstein didn't continue his 1911 gravity study and use calculus to give further details of his theory in an easy-to-understand manner. That is all I used in my 2021 paper and my Quicycle presentation that solves his gravity theory without even using field equations. It is all I used in this presentation. obviously combined with the work of Feynman on changing the electric permittivity of space. Look, perhaps Hilbert was right when he indicated Einstein wasn't such a good mathematician. Then again, why didn't Hilbert, or indeed any other mathematician over the past 100 years, correctly solve his gravity theory? That is left for the others to answer. By presenting his theory with complex maths, he gave himself a place in scientific history as a great mathematical physicist. Well, the best mathematicians over the past 105 years were unable to understand, let alone unravel, their underlying simplicity. Unfortunately, many have followed his example by using extensive maths in other fields of science to show their brilliance. Unfortunately, it must be said that sometimes they have also missed the underlying simplicity, and their answers may not necessarily be correct. This puts Newton's and Einstein's contribution into perspective. In 1687, Newton published his inverse square law and the elliptical orbit, with the sun at one of its focal points. He used logical maths, virtually starting from scratch. In 1916, Einstein published complex field equations that predicted a 2 in 10 to the minus 8 change in Mercury's orbit beyond that predicted by Newton. Those who claim to understand them derived a solution that predicts Mercury's orbit should regress. Yet the exact solution to his field equations just reduces to this simplicity. So don't underestimate Newton's contribution. At the same time, don't overestimate Einstein's contribution just because you don't understand his field equations. Having said that, his predictions of gravitational lensing and gravity waves is uniquely original. This approach was different. Newton derived the inverse square law, but gave no reason for gravity to act. Einstein gave the reason for gravity to act as mass distorting space-time. He did not give a physical definition of either space-time or its distortion. He used unnecessarily complex maths. Those who tried to follow his work got it wrong. In this approach, I show the property of space that mass distorts to generate gravity is its electric permittivity. Its absolute value determines the speed of light through space. As photons move away from a high electric permittivity to a low electric permittivity away from mass, their speed increases. Their increased speed means longer wavelength. They are redshifted. Photons moving at an angle to changing electric permittivity are deflected. The radial differential of the changing electric permittivity gives this equation, G equals Gm over R squared e to the alpha over R. That deflection is gravity. I also show that the rotating photon structure of nucleons gives them oscillating electric fields that have the same properties as the Zitterbewegung of electrons. Combining them with Feynman's quantum mechanics studies show they change the electric permittivity of matter-free space. Rotating photons respond to the same changes in electric permittivity as do linear photons. That is why the same gravity equations apply to both particles and photons. All that is done using known physical principles, logical common sense, the simplest possible math, and a minimum number of axioms. Some may say my work on rotating photon models of matter isn't even known. Well, it's been known for over 60 years that particle-antiparticle pairs can be generated from photon collisions, and that particle-antiparticle annihilation generates photons. I accept no responsibility for people being unable to put the two together and come up with the simplest of explanations. Particles are made from confined photons, because John Williamson and Martin van der Mark are excluded from that. They worked it out. Rotating photons are the simplest confinement. Feynman's work on high-frequency electric fields altering the electric permittivity has been known for over 60 years. Other work cited has been known for much longer, some going back to the 17th century. Nothing new about that. This approach used common sense supported by good mathematics. Like Einstein's gravity and Feynman's refractive index studies, it uses approximations. The approximations give a good match with observation. Over the huge ranges of masses studied, the variations between observation and the first approximation theory were less than about 0.05%. This leaves plenty of scope for further refinement. So, what are the advances this makes to our knowledge of gravity? Well, firstly, it gives a physical mechanism by which gravity functions. Then it gives an exact mathematical solution to the form of gravity. Both of the above combine to show that gravity can only be inverse square or weaker. Gravity weaker than inverse square means an infinite steady state universe will not collapse under the gravity of its own mass. That changes everything in cosmology. Through variations in Fn and omega, this mechanism suggests that Newton's gravitational constant g may not be as universal as originally suggested. Measurements using masses of tens of kilograms and densities of approximately 10 to the fourth kilograms per cubic meter may not necessarily be the same for masses of 2 times 10 to the 30 kilograms, which is that of the sun, or 1 billion times that, if they're the massive objects at galaxy centers, and densities varying from 10 cubed kilograms per meter cubed of stars and gas giants to greater than 4 times 10 to the 17th kilograms per meter cubed neutron stars. However, that Newton introduced G was a great advance for his era, and he really was brilliant. Now, the mutual attraction between bodies M1 and M2 is because body M1's electric permittivity overlaps M2's nucleons, and it deflects them towards it. And then M2's electric permittivity overlaps M1's nucleons, deflecting them towards it. It shows why antimatter responds to gravity the same as ordinary matter. And it suggested the ability to visualize how gravity works may make it easier for further calculations of its effect. So I'd just like to make a few concluding remarks so that you can understand, so to make it easier to visualize quantum gravity. All matter particles are composed of photons of the appropriate energy, making 2 revolutions per wavelength. This gives them high-frequency alternating electric fields. High-frequency electric fields change the electric permittivity of space. Vast numbers of nucleons are required to make small changes to the electric permittivity of space around a massive object. It is higher near than the massive object and lower as the distance increases. Photons are deflected when they pass at an angle through a changing electric permittivity. The radial differential, or rate of change of electric permittivity with distance, determines how much they are deflected. That deflection is gravity. Linear photons pass rapidly through the changed electric permittivity around a massive object. Their deflection is small. Rotating photons, that is particles, are subjected to the same deflection. Staying in the same place means the deflection effect is cumulative. If they are unsupported, the deflection of each rotation increases their speed towards the massive object. That gives them their acceleration under gravity. If they are supported, each rotation deflection exerts a force on the supporting body that converts their mass to weight. I respectfully suggest that in the above, it has been demonstrated, or as the Latins say, quod erat demonstrandum. I prefer to use quantum electric permittivity deflection equals gravity. I'd like to leave you. I put together this book. It's something like over 500 A5 pages. It's quite detailed. Chapter 9 describes some of what I've just presented in greater detail, but it really does go through from the smallest subatomic to the large-scale structure of the universe. The area of greatest interest I think people should pay attention to is nuclear binding and the structure of nuclei. This model of particles really does give a very good explanation of all of the things you want to know about nuclear binding and structures that you do not currently understand. Another one of equal importance is the abundance of nuclei, and that is determined by how they fuse. This presentation shows how fusion occurs, and it doesn't occur the way they're trying in their experiments. And I respectfully suggest that if anybody wants to do anything in nuclear fusion, they really need to get hold of a copy of this book and understand everything at least up to here. And I'll leave this with the rest of you. Because gravity is weak in the inverse square, it changes the whole mechanics of the universe. And as I mentioned before, you can obtain this from Quicycle books. That concludes my presentation. Thank you.